Hello geeks! Welcome back to your favorite YouTube channel, My Project Ideas. I am Simran and today we are delving into the fascinating world of data structures and algorithms. Whether you are preparing for a coding interview or looking to sharpen your programming skills, this video is just what you need. We are here to simplify these complex concepts and make them easy to understand. Stay tuned for an enlightening, interesting, and a fascinating session. So, today's topic is gonna be computing power. So, let's have a look that what does this topic mean? What does computing power exactly mean? What is the algo behind it? How does the coding work? And lots of stuff. So, here we go. So, what is computing power? Given two integers x and n, you have to write a function to compute x to the power n. So you have to assume, we have to assume that x and n are small numbers and overflow doesn't happen. So what is our task? To calculate power x to the power n. Suppose x is equal to 5, n is equal to 2. So x power n, that is 5 power 2, will be 25. Simple, easy. Examples being x is equal to n is equal to 3. So 2 to the power 3 is 8. 7 to the power 2 is 49. Easy peasy. Now, how do we code it? There is a naive approach for it. So what do we do? Simple no-brainer, we multiply x n number of times. How do we do it? We can do it simply by using a for loop. Simple concept, but it takes time complexity big O of n and auxiliary space big O of 1. So this is a layman approach, very easy approach. So guys, please pause this video here and write down a code to calculate the computing power, that is x to the power n. You did not do anything, just write a simple for loop and multiply x n number of times. Simple, as simple as that. So I hope you guys have already coded. Now let's code together. So let's create a function def power x and n. There are two parameters. Then we have to initialize the result as 1. Power is equal to 1. Then let's start writing the loop for I in range n. So what do? Multiply it n number of times. So multiply x n number of times. So power is equal to power into the number is x and loop is running from 1 to n. Okay. Next, nothing. Just return power. Return power. Simple. Done. The code is done. Now let's write the driver code. Name is equal to main. Okay. Let's take an example. X is equal to 2 and n is equal to 3. So we know that the answer will be 8. And now let's do the function call. Result is equal to power. Let's pass x and n. The parameters, let's pass it. And let's print it. Print. Done. Let's save it and let's run. So you got the answer as 8. Power is 8. So this is understandable. It's quite easy, but the time complexity is a bit higher. No issues. We always have an efficient code for it. Let's have a look. So this is an optimized code, guys. So what do we do here? We use a divide and conquer solution. We use recursion here. So what do we do? So see, power function with parameters x comma n can be written as power function x comma n by 2 into power of x comma n by 2 if n is even. And again it can be written as power x comma n is equal to x into power of x comma n by 2 into power of x comma n by 2 if n is odd. So these are the recursive functions, because see, we have this function right here, power function. Again we are just dividing the parameter by 2. Again here same thing. So this function is again used. So we are using a recursive call stack here. So what here what happens is, because we are using recursion here, the time complexity is reduced to big O of log n. And auxiliary space will be big O of log n. Why? Because we are using a recursive constant. This is the formula that we are going to use here. So what was the problem with the naive solution, guys? Because the same sub-problem was computed twice for each recursive call. Because see here, even we have one function, one call, and for odd we have another call. But in that case, in the iteration case, you are doing the same thing for both of it. But here what we'll do, we'll optimize the function. Suppose we have a odd, the value of n is odd. So we are gonna use this one, this second line only. If n is even, we are gonna use this first line only. So our loop runs log times, log n times. So we are writing this code efficiently. But there, even if n is even or odd, we were following the same concept. That's why the time complexity was higher. Got it? So now let's have a look at the code. Then you will get to know better. Okay, let's move to the VS Code and let's create another file. Computing power efficient dot. Okay, let's start writing df power. Let's write the parameters. Then if y is equal to 0, okay, this is a corner case. So we are returning 1. Okay, now let's create a temporary variable here. Let's create a temporary variable. Temp is equal to, let's start the recursion. Power of x comma y integer division 2. Okay, we change it to, because the recursion, I wrote that power by mistake. Now let's check for odd and even. Y mod 2 is double equal to 0. So we are here for even. What do? We return temp. Got it? Next. Else, what do you do? If it is odd, we return x into temp into temp. What we discussed in the section, in the PPT section. So guys, we're done. That's it. Now let's write the driver code. If name is double equal to, write main, write your colon. So guys, if you understand the concept now, writing the code becomes very easy. It's a no-brainer, because if you know the language, you can code properly. The thing is, you should know how to figure out the algorithm. So now let's write result is equal to power of, let's pass the parameters x comma y. So here what we did was, the difference what was there, that we took different cases while the power was odd and even. So it reduced our time complexity. The same answer you're gonna get. So guys, I hope you understood the code. I hope you understood the PPT well. The concept was clear. You understood the difference between the naive and the efficient solution, the divide and conquer algorithm. So let's wrap this session for today. And for more interesting project ideas, stay tuned. And with this note, let's end the session that you will be keeping coding. Keep coding, keep enjoying, keep learning.